Okay guys, so we got day 8, practice with chain rule. So I wrote down all of our derivative rules up there. You were supposed to do this with a partner, and you know, the quickest people that came up, I was going to give cards and stuff, but obviously we can't do that, so we can pretend. So you can pause this and you can do these 4 yourselves if you want to, or we can, you can just do them right now with me. Okay, so I'll start up, you choose whatever you want to do. Okay, so let's find the derivative. So the derivative of cosine is negative sine, and the derivative of the sine is the cosine. We could leave our answer just like that, or, if it was multiple choice, commutative property would be used, and it would be written with less characters, cosine x minus sine x. Number 2 looks like chain rule. So the derivative is equal to 5. 8x minus 1, decrease the power by 1, and remember, chain, we got to multiply by the derivative of the inside, so the derivative of 8x minus 1 would just be 8. And we could clean that up a little tiny bit. Let's multiply the 2 monomials. 8 and 5 are 40, so 40, 8x minus 1 raised to the 4th. Okay, just basic chain. Number 3, we have a little bit of quotient going on. So let's look back up at what the derivative of tan is. Derivative of tan is going to be secant squared. And we have some quotient rule here. Okay, so bottom times derivative of the top minus top times derivative of the bottom all over bottom squared. And looks like we could basically leave it like that. There's no cleanup to do there. Okay, one more. So here I noticed that we have product and chain. So we'll call this guy first. We'll call this one the second. And the derivative is first times derivative of the second. Okay, so derivative of cos 3x is going to be negative sine 3x, and then chain rule times derivative of the inside. Okay, plus second times derivative of the first. Okay, and then we'll just clean it up. So if we clean that guy up, it looks like we can multiply the x, the negative, and the 3. So negative 3x sine 3x plus cos 3x. And that's it. Okay, so hopefully you did well with those guys. All right, so we're just going to do just some more practice with chain. Let's see what we got here. Okay, so we can see that we have chain rule and quotient rule. So it's up to you if you want to make that little chart off to the side. But these don't look like heavy duty. They look like they're going to be pretty easy derivatives. All right, the kitty cat is here as usual. Hi, Petey. Don't go in front of the iPad, please. All right, so let's just start it up. Okay, so first thing we're going to do is we're going to do a little bit of chain, right? So it's going to be 4, 2x plus 1 over 3x minus 1. Decrease the power by 1. And now here's where I have to do, the derivative of the inside is going to be quotient rule. Okay, so all of this now is going to be a big multiplication. So I'll just make a big bracket. Okay, so bottom d top. So bottom times derivative of the top minus top times derivative of the bottom all over bottom squared. Oopsie, I don't know, what did I make that last one for? Okay. Okay, so we'll just, we'll clean up probably like that, the mess to the side there. So I'll leave this. and we'll do a little bit of cleanup over here. So maybe we'll do some stuff above it, okay? So right up here, I'll do, for this, I'll do the distributive property, right? And then here, I'll do the distributive property as well, but then I do have a negative. Okay, so let's do some of this up here. So this looks like it's going to be, wait, did I make a little mistake? I did. I made a little mistake. This x should not be here, so just take that out, please. Okay. All right, so the derivative of this is going to be 6x minus 2. And now here, we are going to get, so look, we're going to get 6x plus 3, but then I have to distribute that negative sign. So it's going to be negative 6x minus 3. And now we could combine all of this, right? And if we combine all of that, we're going to be left with just negative 5, right? Okay, so that's going to be a negative 5 all over 3x minus 1 squared. And I guess we could go just a little tiny bit further, right? Just a little bit more. Okay, so I don't want to get crazy on you. If you want to leave it like that, you can. Okay, but if I was in class with you, I would do a little bit more. What I would do is I would take this power of 3 right here. This guy, I would take that power of 3 and I would distribute it to both of them, and I would write it like this. Again, we're just going a little higher level here. If this is too much for you, then just stop. And you'll see why I'm going to distribute that. All right, and then I'm multiplying still by this. Okay, so the reason that I did that, because now on top I'm going to get negative 20, right? 2x plus 1 raised to the third. But look what I'm going to get on the bottom. On the bottom, I have a base raised to the third, and then I have the same base raised to the second. So can I just keep that base? And when we multiply, we add the powers. Okay, so that's a little much. That's too much for you. That's totally fine. Stop a couple steps up above. Okay, but I did want to show you that. Okay, next. I think that I have a repeat question. This is like a typo. Yeah, so skip that one. Okay, and let's practice a little bit of chain with tan. So remember, derivative of the tan, you do have to, try to memorize these, is secant squared. And I do see chain going on. Okay, so derivative of tan is going to be secant squared of all of that, right? And then chain rule times the derivative of the inside. So I think I'll just use a little bracket. So the derivative of the inside is going to be 6x plus 2. Okay, and you can leave it like that. That's fine. Oh, sorry. All right, 3. I reminded us here, derivative of sine is cos, derivative of cos is negative sine. Okay, so let's check out this crazy looking guy. Definitely see chain again going on here. All right, so the derivative is, so don't be concerned with what this inside is, that you're going to take the derivative of that after. So really you're asking yourself just what's the derivative of the sine. So the derivative of the sine is cos. So it's cos of cos x. I know that's weird. And now times the derivative of the inside. So the derivative of cos is negative sine. Now, if you want to rewrite that without all those parentheses, we can move that sign to the front in the negative and write negative sine x cosine of cos x. Okay, so a little weird, this one. Okay, but that would be how you would write your answer. Okay, 4, yeah, we're going to skip. 4 is just a little crazy. We don't need to do that one. It's kind of just insane. All right, and then we're going to end on number 5, which is just a review question. So it says, given the function f of x, we can see I'm giving you a piecewise function. All work must be shown. The first thing I want to know is it continuous at x equals 1? So I'm bringing back just some review topics here. If I want to know if it's continuous, remember there's 3 steps to continuity. So the first thing we're going to do is, why is this not working? Oh my gosh, what am I doing? Okay, let's try again. Okay, guys, I don't know, why is this not writing? Weird. Why isn't my pen writing? Okay, why is my pen not writing? Kay! Kay! Yeah. Can you come help me for a second, please? Yeah. Okay, hold on one sec, guys. Let me see if my daughter can figure this out. Otherwise, I guess we're not doing this question. I can't get my pen to work. It like froze. I'm in the middle of doing a video, though. But I think it's like frozen. Look, I have the pen on. Can you try? So put the pen on. Right, it's like frozen. Should we close out of it and then go back in again?
Here?
The last one. Yeah, this one. Oh, okay, great. All right, thank you. Okay, guys, sorry about the little technical difficulties there. All right, so, but I wasn't starting this video over. Okay, so we have 3 steps to continuity. So the first thing we're going to do is see if a function value exists. So is there a value at f of 1? So f of 1, which piece of the domain are we plugging it into? We're going to plug it into this piece, right? X is less than or equal to 1. So if I place in 1, 4 minus 2 times 1, we get 2. So a function value does exist. Okay, does the limit exist? So what's the limit as x approaches 1 of f of x? Since it's a piecewise function, we have to put it into each piece and come from the left and the right. So x approaches 1 from the left, and the limit as x approaches 1 from the right. Okay, so from the left, we're looking at a little bit smaller than 1, so we'll plug into the top piece. We already found that that was 2. X, as the limit as x approaches 1 from the right of 1, so a little bit bigger than 1, so we'll plug in here and we get 2. So these guys are the same, so that's good, right? So the limit exists. And now, does the function value equal the limit? And it does, right? So therefore, this is continuous. Remember, just because it's continuous does not mean that it's differentiable. Okay, so now let's go over, in order to find if it's differentiable, remember, it has to be continuous. You can't just jump to the differentiable step, because I showed you that, where sometimes it'll appear that it's differentiable, but it wasn't continuous. So therefore, it technically is not differentiable. Okay, so now what we have to do is we have to do the derivative. So let's take the derivative of the function. So the derivative of each piece. So 4 minus 2x is going to be negative 2 with the same domain. The derivative of x plus 1 is going to be 1 with that same domain. And now we'll do the same thing we just did, the 3 steps to continuity. So we'll do, does a function value exist at 1? So what is the function value at 1? So at 1, that would be this piece right here. We're going to get negative 2, so the function value exists. Now we'll do the limit as x approaches 1 for the derivative. We have to approach again from both sides. But we can clearly see now, so I'm just going to use a different pen. If we do this piece right here, the limit as x approaches 1 from the left, a little bit smaller, we're going to get an answer of -2. And then as we approach 1 from the right, a little bit bigger, we're going to get 1. So these guys are different, right? So the limit does not exist. You can write it like this, or you can write D and E. It does not exist. So our last step then, the function value does not equal the limit. Okay, they do not equal each other, so therefore this is not differentiable. Okay, so just an old little question there. All right, good job, guys.